Here we have a problem on derivative. Okay, let's go to the question. Given that y equals to 2 raised to the power of x square, find dy over dx. Okay, in the given function, we have to find derivative with respect to x. Okay, let me write the given function as it is. That is y equals to 2 raised to the power of x square. Okay, to find dy over dx, what I have to do is I have to find derivative of this y with respect to x. When I do derivative with respect to x on the left side, on the right side also I have to do derivative with respect to x. Here we have variable at the exponent here. When I have variable at the exponent, it's a bit difficult to find derivative. So what I have to do is I have to get rid of this variable at the exponent. How can I get rid of this variable at the exponent? For that, what we have to do is we have to take a logarithm on both sides. When we take logarithm on both sides, we can use the properties of logarithm. In particular, we can use the power rule of logarithm on the right side over here to get rid of this variable x square at the exponent. Okay, so whenever I want to find derivative with logarithm on both sides, always I have to take natural logarithm on both sides, because the derivative will work only for the natural logarithm. Okay, now let me take natural logarithm on both sides. When I take natural logarithm on the left side, I'm getting ln of y. On the right side, I'm getting ln of 2 raised to the power of x square. Okay, here on the right side, I can use the power rule of logarithm. That is, if the argument of a logarithm is power, then what we can do is we can move the exponent that we have at the argument in front of the logarithm, and it has to be multiplied by the logarithm. So this is called power rule of logarithm. Okay, now let me keep the stuff on the left side as it is. That is ln of y equals to, now let me move the exponent the argument in front of the logarithm. Then I'm getting x square times ln of 2. Actually, this ln of 2 is a constant. Because 2 is a constant, when you find natural logarithm of 2, so again we'll be getting a constant. So this stuff has to be considered as a constant. Now this variable is multiplied by this constant. Okay, now what we can do is we can find derivative on both sides. Let me do it. So differentiate with respect to x on both sides. Okay, so whenever I find derivative for a natural logarithm, I have to take 1 in numerator, and whatever argument I have over here, it has to be taken in denominator. So far I have completed derivative only for this natural logarithm. By chain rule, I have to do further derivative of this argument y with respect to x. Then I'm getting dy over dx. Okay, here this variable is multiplied by the constant. When I find derivative of this x square with respect to x, I'm getting 2x times, we have to keep the constant as it is, that is ln of 2. Okay, now to get up the denominator y over here, what I have to do is I have to multiply both sides of this equation by y. Okay, let me do it. Y times 1 over y times dy over dx. On the right side also we have to multiply by y, that is y times 2x times ln of 2. Here this y will cancel, then I'm getting dy over dx on the left side. On the right side, for this y, we can plug in this stuff, 2 raised to the power of x square. Then I'm getting 2 to the power of x square times 2 times x times ln of 2. Okay, then we get dy over dx equals to, here for this 2 we can assume there is exponent 1, because for any term, if there is no exponent, we can assume there is exponent 1. So here we multiply two terms with the same base 2. Whenever we multiply two terms with the same base, what we can do is we can take the base ones and we have to add the exponents using the product rule of exponents. When I add the exponents, I'm getting x square positive 1, and here we have x 2 to the power of x square positive 1 times x times ln 2. So this is a result of dy or dx for the given function.